Okay, so today we are going to discuss basic mathematics logarithm chapter. This PDF belongs to Motion Academy. We are going to just refer to this and we are going to study number system and basically about numbers, about fractions, and also about logarithm. So starting with number system. So as we know, mathematics in our childhood, we learned mathematics from counting first, right? We used to count things. Like if there is one banana, there is one banana. There are two bananas, so two, three banana, four banana, five banana, six. So whenever we count anything, and if it is present there, then those numbers are known as natural numbers. The counting numbers, 1, 2, 3, 4, 5, and it goes on and on and on, are called natural numbers. The set of natural number is denoted by capital N. Thus, N is also denoted by I positive or Z positive. We are going to discuss what is I or Z later. So, is everything clear about natural numbers? What is natural number?
Yes, sir.
And if we include the condition that there is no banana, like there's no banana, and we count no banana as zero. If there is, if anything is, if anything is not present there, we call it as like there's zero banana. Or there's, if we are discussing about zero. So if we discuss and include zero also in our counting, then the natural numbers including zero are called whole numbers. The set of whole numbers is denoted by capital W. Thus, W is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and goes in on. So, W is also called as set of non-negative integers. We are going to further discuss what is non-integers and what is non-negative integers. Is everything clear about whole numbers?
Yes, sir.
Great. So, discussing about integers. Numbers which are complete, like whole numbers were 0, 1, 2, 3, and it were going on to positive infinity. We do the same to the negative x's only, to the negative side also, and go number are going to the minus of infinity. Now all these integers, like all these points where numbers are not having any fractional value, are complete, and they are not having any decimal. These numbers are called as integers. So the numbers from minus infinity, minus 3 to minus 1, 0, 0, 1, 2, 3 are called integers, and the set is denoted by I or Z or Z. Great. So these are integers. Is everything clear about integers?
Yes, sir.
So minus 5.5 is an integer.
No, sir.
Great. And is 0 an integer?
Yes, sir.
Yeah. So integers are the set of these numbers and set of positive integers. It means that we are just avoiding the negative integers in this. So set of positive integers are 1, 2, 3, 4. They are also natural numbers, right? And set of negative integers which are negative, so which are negative in nature. So minus 1, minus 2, minus 3, minus 3 goes on and on to minus infinity. Set of non-negative integers. Now these are special. Understand one thing, that we are avoiding negative integers. So these were negative integers and the whole integers set was this. So if we avoid this, avoid the integers from the negative integers, like if we don't see the left on minus 1 and also minus 1, what is remaining is 0, 1, 2, 3, 4, 5. So 0 is included in this. That's a special thing because uh, it's not 0 is not negative, so that's why we have included this 0, 1, 2, 3, and 0 is neither positive, so that's why set of non-positive integers will also have 0, right?
Yes.
So one this note this point. So this is about integers. Everything clear?
Yes, sir.
So this is about even integers. Integers which are divisible by 2 are called even integers. So whichever is divisible by 2 are even integers, 0, 2, 4, 6, plus minus. So because they are integers, not natural numbers. That's why minus numbers are also, negative numbers are also considered. Clear about even integers?
Yes, sir.
Odd integers, integers which are not divisible by 2 are called as odd integers, plus minus 1, 1, 3. So what is oddness and evenness? Let's discuss what is oddness and evenness. Whenever we discuss anything, let us say oddness, in the word itself, we have odd. Odd means something which is extra. When it comes to evenness, so when everything is adding up and everything is having some pairs. So if there are like 8 bananas, so there are pair of or there are a pair of two. So how many pairs are there? 4 pairs of banana are there. But if there are like 9 bananas, which is an odd number, so how many pairs are there? 4 pairs and one banana, which is the oddness, right? So that's why we call it as odd because it's not able to pair itself in the form of twos, right? Like we know in armed forces, whenever people are sent, they are sent in even numbers. So that like they have a buddy system, one person will have the buddy, and another person will also have the buddy. So they are sent in even numbers. Because they want to be even. One looks for the other, and other looks for the first one. Right? Clear about evenness and oddness?
Yes, sir.
Yeah. So even integers, odd integers, prime numbers. So prime numbers are the natural numbers where p is said to be prime if any number have exactly two distinct factors, namely 1 and itself. So any natural number, simply putting, any natural number having only two factors, 1 and the number itself, are prime numbers. Like for example, these are some prime numbers. Here we can see 2's factors are 1. 2 will be, factor means factors are those natural numbers by which the number which we are discussing about will get completely divided. Like 8's factor can be 1, 2, 4, and 8, right? All these four numbers will divide 8 completely, and it cannot be 16 because 16 will not be able to divide 8 completely, right? And what do I mean by dividing it completely or not? It is that key whether whenever I divide something by something, then the remainder have to be zero. And if the remainder is zero, so that's what I'm referring to as a complete division, right? Are you with me?
Yes, sir.
Yeah. So the factors of 2 is 1 and 2. Factor of 3 is 1 and 3. There cannot be any other factor because it's a prime number. Same goes for every prime number, that there will be only two factors of these. 1 and the number itself. So these natural numbers are termed as prime number. Everything clear about prime number?
Yes, sir.
Yes, Tanish, everything clear?
Yes, sir.
Yeah, please unmute yourself and keep on responding. There are some notes. One is neither prime nor composite. Okay. One is neither prime nor composite because its factor is just 1. So it's hard to uh, term as prime or non-prime. And non-prime numbers are composite, basically. Simple. Composite numbers are non-prime numbers, which have more than two factors. So one do not have more than two factors. Even one don't have two factors. So it's a special case. 2 is the only even prime number. So when we discuss about even prime numbers, So 2 is the only even prime number. Like it's the only even. It's the only even prime number. There are no other prime numbers, because if we discuss about any other prime number, like let's say if there is a number like this, so it is bound that it will be having 2 as its factor and also the number itself. So there are three factors, right? So if there are three factors, then the odd number cannot be prime number. But in the case of 2, the n is here 1. So n is here 1. So this becomes 2 only. So there will be only two factors for 2. That's why 2 is able to become a prime number. So this is also one more important point, right? Clear?
Yes, sir.
Composite number simply any natural number having at least three distinct factors, and the number of factors can be greater than this, but at least three distinct factors. Distinct means different factors. Clear about what is composite number?
Yes, sir.
Now tell me what is the smallest composite number? Anyone?
4, sir.
Good. 4 is the smallest. 4 is the smallest composite number. Okay, this kind of questions can be asked in short or like statement type questions can be asked. So one is neither a prime nor a composite. Numbers which are not prime are composite numbers except one. Okay, numbers non prime numbers are composite numbers except one. We have seen the case of one, right? And 4 is the smallest composite number, and 2 is the only even prime number. These are some special things. So let's discuss about co-prime numbers now. So these are pairs, two natural numbers, not necessarily prime, are co-prime if their HCF, highest common factor, is 1. Now, HCF means common factor, like highest common factor. If we are writing the factors of two numbers, let's say A and B, if we are jotting down all the factors of them, and if we see if we match common factors, okay, and the highest common factor which will be matching, then that will be our HCF. Or using prime factorization method, we can also find out HCF. I want you to find out the HCF of write something hard of these two numbers. 16 and 96, what is the highest common factor?
One minute, sir. I'm just doing it.
Okay.
Sir, is it 16?
I've checked. So we'll first write the prime factors of both the numbers, and we'll match the common terms, like 2 raised to power 4 and 2 raised to power 4 is common. Nothing is common than that. And 2 raised to power 4, and if the other terms are also common, so we'll multiply by them. So 2 raised to power 4 is 16. So yes, 16 is the correct answer. 16 is the highest common factor. Now let's discuss more about factors. Factors were what? Factors are the numbers which simply divide the given number completely. So 1, 2, 4, 8 are the four factors of 8. And about multiples, multiples are infinite numbers. They are not finite. Factors are finite numbers. Multiples are those numbers who are multiples of 8. Simply 8 was a 8, 8 was a, and we can go on and multiply the whole natural set with the given number, right? So when we are discussing about highest common factor, so it's a F factor. When we are discussing about LCM, so it's the least common multiple. This is a multiple, like LCM of 8 is 8. But if we write another multiple, like multiples of let's say any number, 28. So multiples of this number is 28, and 28 2 ja 56, 28 3 ja 4, and then 84. If I do any mistake, please correct me. 28 4 ja something like that. So we are going to then see the multiples. If we find any multiple common, LCM, any multiple common, so that will become and any multiple common, and among all those multiples, the lowest will be the LCM. And also there is like better method to find LCM using prime factorization method. So is this clear about HCF and LCM?
Yes, sir.
Yeah. Even prime numbers. So no, first co-prime numbers. So any two natural numbers need not to be those two natural numbers need not to be a prime number, but it is just that the highest common factor in between them must be 1. So basically, their factors must not be intercross their paths, or they must not be similar. Like 3 and 8, if we list their factors, there are no factors which are common except in 1. Same goes for everyone. So this particular set will be known as the co-prime numbers, co-prime numbers, co-prime numbers, like this. These numbers are also called as relatively prime. Prime means is something of primeness, right? They have something special and unique and very much different to other. So, like these numbers were prime. They establish other numbers on based on this. Like on the if we find out any prime factor, factorization of any number, prime factorization. So these numbers make numbers unique, right? If 2 were not there, the whole even number will not be there. If 3 will not be there, a lot of numbers will not be there in your number system. So these are the numbers, these are the primes. So same goes for the primeness of where is co-prime numbers, where they are in a should I say, just like a frog is in a well, and the frog thinks that the world is this only. The same, they are thinking the bracket is this only, and we are relatively prime. I'm different than 3, and this says I'm different than 1. I'm very much different. So they are not having any common factors. So that's why they are known as co-prime numbers. Okay. Any doubts about it?
No, sir.
Okay. There are some remarks. Numbers which are not prime are composite numbers except 1. Who is the smallest composite number? Oh, ये दिख तो नहीं रहा था. Was it visible when I was asking question? Okay, anyways, two distinct prime numbers are always co-prime, but converse need not to be true. Means two distinct prime numbers, if there are two prime numbers, let's say 2 and 5, are always co-prime because they are prime in itself with compared to whole natural numbers. So if they are compared to each other also, they are going to be co-prime. But if we think and if we take any two numbers, 3 and 8, and if they are co-prime, and if we say that if these two numbers are co-prime with each other, so they must be prime numbers also. So that converse is not okay, because 8 is not a prime number here, but 3 8 is still a co-prime co-primes example, right? Understood?
Yes, sir.
So consecutive numbers are always co-prime numbers. Consecutive numbers means any number 1 and 2 are consecutive, and 2 and 3 are consecutive, then 3 and 4 are consecutive, then 4 and 5 are consecutive. Basically, the gist is that any number and any number next to it, they are co-prime numbers. The factors are not going to match. This is one point to note, right? We can take example of 1 and 2, 2, 3, 4, 5, 18, 19, 90, 90, 91. They are all co-prime numbers because they do not have common factors. Clear? What is co-prime?
Yes, sir.
Discussing about twin prime numbers. If the difference between two prime numbers is 2, then the numbers are called as twin prime numbers. 3, 5, 5, 7, 11, 13, 17, 19, 29, 30. These all are prime numbers, and the difference between them are also 2. They are known as twin prime numbers. Understood? Not so important. Clear?
Yes, sir.
Yeah. I want you to note this as an homework that you have to learn all the prime numbers till 100. Is there anyone who can now tell me and tell me the all primes till 50? Anyone? Okay,
No,
not all.
sir.
Yeah, so learn all prime numbers till 100 and at least 50. And also learn some fact that how many prime numbers are there from 1 to 10, 1 to 25, 1 to 50, and 1 to 100. How many prime numbers are there? Right? These are two homework. Please take a snapshot of this. Done?
1 minute, sir. Yes, sir.
So let's now discuss about rational numbers because we are learning about numbers and if you have base strong, so it will be useful at many places and also our chapter probability. So let's now discuss about rational numbers. All the numbers, those can be represented in the form of P upon Q, where P and Q are integers. Integers are basically numbers, whether they are positive or negative. And Q must not be zero. So, 0 is also an integer, but the base should not be zero, otherwise it will become an infinity or not defined number. So rational number, as we know about the definition of rational is something which is rational to us, like the same smart numbers. So rational numbers and the set is denoted by Q. Let me repeat, any rational number that can be represented in the form of P upon Q, where P and Q both are integers and Q must not be zero. So any such number is known as rational number. Clear?
Yes, sir.
And it may be noted that every integer is a rational number. How? Like let's say 4. So 4 is having 1 in the denominator. So this is also a rational number. Every integer is also a rational number. Clear? Clear about rational number?
Yes. Yes, sir.
Yeah. So maximum number of different decimal digits in P by Q is equal to 11 by 9 will have maximum is equal to Q. Okay. So let me write somewhere an important note. Maximum number of decimals, different decimal digits. Note the word different decimal digits in P by Q is equal to q, which is an integer. Let's say for 22 by 7, and mind it, 22 by 7 is not pi. It is approximately equals to pi. It is approximately equals to pi. It's not exactly equals to pi, right? Pi is an irrational number. It just don't ends. So pi is approximately 22 by 7. So if we take the example of 22 by 7, 22 by 7 is a rational number because 22 and 7 are integers and 7 is not 0. Okay. So the different number of digits in the after decimal will be 7 here. Right. So 22 by 7 will have maximum of 7 different decimal digits. That's the point. Okay, not much, very much important, but it's interesting to know new things every time. Clear?
Yes, sir.
Yeah. So let's discuss about irrational numbers. So irrational numbers which do not have any rationals or any mind or reason. Anyways, irrational number. These are real numbers which cannot be expressed in P by Q form. These numbers are called irrational numbers, and the set is denoted by QC, which is a complementary set of rational numbers, or Q bar. No, or Q complement. Complement is can be represented by C or Q apostrophe S. Not apostrophe only, not S. So complementary set of Q square root of 2. This is a shard. We are going to discuss what are shards. So square root of 2 and even the mixed shards, which are like the additions to any irrational number, will also make the whole number as irrational. And E, which is a Napier's analogy, which is a Napier's constant. E is approximately 2.71. It is not equals to 2.7. Pi is also approximately 3.14, and pi is not equals to 3.14. Just there are also other decimals. Let me. So let's look at its graph. It's a mathematical constant given by Napier, and the limit, you can see the sigma over there, and see E is 2.71828, and it goes on and on. So it just don't ends. See, and it's not ending here also. After 6, it's not ending, it's just going on. So this is irrationality in numbers. This is how irrational numbers can be, right? Understood?
Yes, sir.
Same if we understood, if we search about pi. Pi is also a number which just don't ends. See how irrational a number can be. And still it's not ending after dot dot dot. 3.1415926535897932384. It's just not ending. Okay. So now this is how rational numbers can be, and square root of these, these square root numbers, all shards are irrational numbers. And remember that square root of 4 is not an irrational number because it solves to 2. Okay, so these are irrational numbers. Napier constant pi also is an irrational number, and any number which is having square root and which is not solvable, it's also an irrational number. Correct? Any doubts?
No, sir.
Okay. So let's discuss what are shards. Shards are nothing different. We are already aware about them, but it is just a representative of square root of root of any number. Like if any number is having having its power in exponent 1 raised to power n. It is just another representation of this. So we just call them as third, and if it is not further solvable, like if A is not a perfect nth power, which is if let's take a case which is otherwise. Let's take 2 raised to power 5, and we are also having its root, which is having 1 by 5 power. So 2 raised to power 5 upon 1 by 5. So that comes out as 2. So this case is not allowed, that it should not be a perfect nth power. If 2 had raised to power 10, then also it would not be known as a shard, right? Because we are able to solve it. So these are sets clear about of nth order. Like if its power is 1 by n, so it is of nth order. Shard is shard of nth order with base A, and base A must not be having any perfect nth power. These are simply root 2, root 3, okay, root 2, 3. And here 3 is represented. So what it's mean? That 2 is 2 raised to power 1 by 3. Clear? Clear till then, whatever I have taught till then.
Sir, any other example for surds?
Um, any other examples for shards? Just example is this only, like there is a exponent with base which is not perfect nth power. Let me understand you with another example. Let's consider a scenario which is define the current definition of shards. Space. They are just simply known concept which we are just giving a new term to it. So what is happening here is any number is there, and it's in its power there is 1 by any number, but it will be known like this number will be known as shard on just if it just satisfies one condition, that is A must not be having its power in perfect n multiples. If A's power is like in this term, so then what is going to happen next is this is going to become an exponent. It's simple. So in this particular case, then it is not a shard. And if this is not present, that in its power n is the power is not the multiple of n, then it's not going to be solve for some other, like if we say a can be written as k raised to power l. Now L is not divisible by n. So if we take its power 1 by n, 1 by n. And if L by n, L is not completely divisible by n, then it will be known as shard. Let's take an example. Let's take an example that 2 raised to power 5, it is a number, it is a base, and we are discussing about 1 raised to power 7. So now in this case, if like it's the maximum power, so if 5 by 7 does not solve to any integer, or 5 is not getting multiplied by 7 completely, so now it will be a case, then a will be written as in this format, and it will not be solved further. 2 raised to power 5 7. So it won't be sold as it cannot be sold further, and that's how we are not calling it as a shard. Absurd. So it's a shard. That's it all. Clear about shard? What are shards? Basically having square roots or any roots, having any roots which are not solvable. which are not solvable. Clear? Or should I give more example?
No, sir, clear.
Yes. So if we have opened this page, let's discuss one more thing. About number system. So the great OG and the like originator of any numbers, whole numbers are in this set complex numbers. Means they have imaginary number, they have pure imaginary number, and they also have real numbers. We are going to discuss about complex number ahead. Let's first understand about real numbers further. So real numbers, the union of rational numbers and irrational numbers are real numbers. Rational numbers we already discussed can be represented in the form of p by q, and irrational numbers which cannot be represented in the same form. So rational and irrational numbers are there. Rational numbers have fractions and integers. So irrational numbers have real numbers that are not rational simply. So rational numbers are further divided into fractions and integers. The integers are further divided into positive integers, and positive integer will have a natural number are simply natural numbers, and natural numbers will have prime and composite numbers. The numbers which are prime will not be composite. The numbers which are composite will not be prime except one. And all the integers excluding 0 are I naught. Negative integers basically are also are not natural number, of course. Negative integers are basically minus infinity to minus 1, minus 2, all these numbers. A whole number, natural numbers including 0, even numbers, the numbers which are able to divide it into two parts, like 0 plus minus 2 plus minus 4 plus minus 6 plus minus 8. Odd numbers which are not able to get completely divided by 2, these are odd numbers. And when we are discussing about odd integers, then we'll write plus minus. Otherwise, odd and even numbers are basically considered as 0, 2, 4, 8. These are odd numbers. And sorry, these are even numbers, and odd numbers are 1, 3, 5, 7, like this. Okay. Whenever we write number, we generally consider them as a natural number. Otherwise, even integers will have plus minus sign included. Clear?
Yes, sir.
This is also a revision. So where were we? We were discussing about
We
search.
were in search, sir.
Yeah. So in an expression of the form, the denominator can be rationalized by simply multiplying numerator. We know about rationalization simply if there is a certain this kind of certain situation in the denominator, so we will multiply square root b minus c. We'll change the signs. Root b minus root c and root b minus root c. So it's basically multiplying by 1, which will not have any effect on it. So now in the denominator, we can see there's a situation like a plus b into a minus b. So it can be written as a square minus b square, which is b minus c, and it will look like this something. So it is more simplified. The denominator is more simplified. So that's this particular process is known as rationalization. And whenever there is any root, even it's not just in the C case, and if C is not having any root, then still we can apply this method to get rid of roots in the denominator. Clear?
Yes, sir.
Yeah, conjugate is basically we are we are just changing the sign of the second term. Okay, or we are just multiplying the whole we are changing the sign of one term only, otherwise it would have been minus root b minus root c. So we are changing the sign of one term only. That's known as conjugate of root b plus root c. So if x plus y, x plus root y is equals to a plus root b, where x, y, a, b are rational numbers, then it is for damn sure that x is going to be equal to a, y is going to be equal to b. Clear? And let me repeat, if this is another point, this was another point completely. So if there is a certain equation in which x plus root of y is equals to a plus root of b, and x, y, a, b are rational numbers. So mostly they are rationals whenever we discuss about numbers. So then it is bound to happen that x will here equal to a and y will be here equals to b. Is this thing clear? Or not? It is like that key if there is 2 plus root 3 and if you are having any question in which you are having this particular situation on the right hand side and it is given that m and n are rational numbers, so m will be equals to 2 and n will be equals to 3. Now clear?
Yes, sir.
Yeah. So here's an example. We don't need to do such things in our NDA paper. Let's discuss. Prove that logarithm of the base 3, 5 is irrational. So if it is rational, first we are assuming that it is irrational. So what we will do, where P and Q are co-prime numbers. Okay, so 3 raised to power P by Q, they have written as, they have basically taken anti-log on both sides. So after taking anti-log, this will become 3 raised to 5 and basically whatever their base is, its power will become P by Q and 5 will go on the right hand side. So they have done the same, and after dividing after they have divided the power 3 raised to power p. This should be equals to 5 raised to power q, which is not possible. Hence, our assumption is wrong. Why it is not possible? Because any multiple of 3 cannot be equals to 5. Like all the multiples of 3 are this 3, 6, 9, this, and 5's multiple are this. So 5's multiples will be having 5 on the last place. Sorry. No, it's not about multiple. It's about power. It's about power. So 3 raised to power 1 will be 3, 9, then 27, then 81, then 12, 4, 3, 7, 2, 9, like this. 5's power are 5, 25, and then again 125. So all the 5's power will be having 5 at its unit digit, and all the numbers of 3 having powers will be having 3, 9, 7, 1, 3, 9, 7, 1, 3, 9, 7, 1 on its unit digit. So it is bound to happen that for any P and Q being integers, here co-prime should not be the number, should not, it is a misprint, it should be integers, right? Because to make a p by q to be a rational number, it has to be that p and q are integers and q must not be 0. So it is the case, it is the case here also. For any p and q being integers, this condition will never be able to satisfy because of the reason I have given this. Are you able to understand that why they are not going to be equal for any value of p and q?
Yes, sir.
Or should I repeat?
Could you repeat it again?
Yeah, for sure. So if we just observe the pattern, like 3 raised to power p, okay, laptop, yeah. So 3 raised to power p, where p is p is an integer. So 3 raised to power 0, it cannot happen because p cannot become 0. Yes, p can become 0, but q cannot become 0. 3 raised to power 1. So 3 can become 1. 1 like p can become 1 also, 2, 3, 4, and it will go on like this. 3 raised to power 0 is 1. 3 raised to power 1 is 3, 9. It is 27. It is 81. and the next will be 2, 4, 3, the next will be 7, 2, 9, it will go on like this. So if we notice the unit place of all the powers of 3, it is having 1, 3, 9, 7, 1, 3, 9, and then again the next term will also be having 7 on its unit digit. Unit digit is the rightmost digit of any number. So it is that unit digit are coming as 1397, and it's a periodicity. After 4 they are repeating over and over. And now if we discuss about 5 power, 5's power cannot be 0, right? Why 5's power q cannot be 0? Why? Because if rational number is written as p by q form, so if q becomes 0, so the whole number becomes not defined, which is not a rationality. So it will go on like this. And if we write 5, 25, 125, 625, so whatever numbers are going to come, the unit place are 5, which was not a single case in 3 raised to power 5. 3 raised to power in 3's powers, right? So for any p and q, these two cannot be equal. So they just cannot be equal. Understood?
Yes, sir.
Because the unit digit, if their unit digit are not equal, so baki we do not care about the other numbers. If their unit digit itself is not equal, so how those two numbers are going to be equal? So that is the logic we have used. Clear? Interesting?
Yes, sir.
So this is how we proved. Anyways, prove this kind of questions do not come, but the concept may be useful for us. This is a term in which we have to simplify. For that, we'll simply do one thing is that we'll multiply it by 3 plus root 5 plus 2 root 2 and 3 plus root 5 plus of 2 root 2. We have changed the sign of one term. We have changed the sign of only one term. Now what we'll consider, we'll look this as A, this as A, and this term as B. This term as B. What is there in the denominator here is a plus b into a minus b, which is an algebraic identity. So we'll write, they have written in this format. The numerator is getting multiplied by 12, and in the denominator, the jadoo is happening, the magic is happening. 12 into 3 plus this and this, and this has become 6 plus 6 plus 6 plus 6 root 5 further. And if you want to further simplify, what we are going to do, we are going to change the sign of root term, and we'll do it like this. Yes, right? And also before doing that, we can take 6 common out of this, and here will be 1, here will be 1 again, 6 can cancel, 12 now 2. So 1 plus root 5, 1 minus root 5 can be multiplied here, 1 minus root 5 can be multiplied here. 1 plus root 5 into 1 minus root 5, a square minus b square, a minus root 5 square is 1 minus 5. So minus 4 in the numerator, in the denominator. Let's see how they have solved further. Yeah, so they have done the same. They have taken 6 common. After taking 6 common, 12 will become 2 here. Understood? And they have followed the same procedure, made 4 in the denominator, and they have solved it further. They have brought all the terms in the numerator. It might not happen in your case because here 4 was able to cut 2 and also the 2's which was available inside. But still, root will be gone from the denominator part. So that's the utilization of rationalization method. Understood?
Yes, sir.
Great. So further, they have solved for the example of this way. Finding the square root of this number, which is an irrational number. Now they have Latin the square root of this as equals to root of x plus root of y. Then they have squared on both sides. So a plus b square is a square plus b square. So a square plus b square into 2ab is equals to 7 plus 2 root 2. The square will be gone if we'll square this. So now 7 is equals to x plus y, then xy is equals to 10. So we'll simply find any two numbers logically fitting. So 5 and 2 are those two logical numbers. And it can be also we can also take x is equals to 2 and y is equals to 5. It's not going to change anything. So this is the answer. Clear?
Yes, sir.
Yeah. Example number 4, prove that cannot be represented in p plus root q form. Okay, so we will first, whatever we have to prove it to be in certain way, we'll just assume it's, sometimes we will just assume the opposite of it, and we will then show them that how this is possible or this is not possible by solving some further calculations. So we're understanding it by, they have just assumed it as p plus root q, and after that they have cubed on both sides. After cubing, so 2 raised to power 1 by 3 is the power, and if after cubing the power will become 1. 2 plus its cube, so a plus b whole cube is a cube plus plus b cube plus 3 sorry, a plus b whole cube is a cube plus b cube plus 3 into AB. I'm forgetting the formula. Go ahead. It should be 3a square plus 3ab square, something like that. Yeah, so they have done the same on the right hand side, and after comparing, they find out since q is not a perfect square, it must be, which is impossible. So, okay. And given was that P and Q was irrational numbers, Q was more than 0 and is not a perfect square. So it was given in the question that Q is not a perfect square. So 3p square plus Q cannot be a perfect square. How? How? So 2 is equals to PQ plus 3PQ plus 3p square. So now they are comparing 2 with this. So PQ plus 3PQ 3p square. Since Q is not a perfect square, so Q perfect square nahi hai, it will remain like this. This will be a short. This will be an irrational number. So now it is an irrational number. Then how it will be equals to 2? We know that any rational number and irrational number, when it gets added, the whole unit will become irrational number itself. So if there is an irrational number written over here, and if there is an irrational number here, then it must happen that the other terms must cancel this, which is not happening right here. So that's why our assumption is wrong. So that's how we have represented, we have proved that this cannot be represented in this method. Clear? Any doubt?
No doubt, sir.
Okay. So whatever is remaining, we will discuss it in the tomorrow's class. Any doubts from today's class or any suggestion for me?
No, sir.
Okay. So I'll share the PDF in the WhatsApp group. You can refer to these PDFs and you can revise. Also, please do the homework and also go back and solve some LCMs and HCF. Read about them and also read this PDF.
Okay, sir.
So